new Kafka RAG chatbot video. In this session, you will learn how to create your own chatbot so that you can present to your manager and you can rock in your team. Okay. Why I named this as a Kafka is because I'm using the input data, which are nothing but our PDF files, which are based mainly on Kafka. If you take your own PDFs like medical, you can name this as medical RAG chatbot or just medical chatbot. If you take documents regarding the Python, you can name this as Python chatbot. You can do anything. Why we need this RAG chatbot? The name RAG is nothing but Retrieval-Augmented Generation. Retrieval in the sense retrieving the data from your database. We call that as vector database, and augment, enhance the input. It is nothing but your prompt and then generating through the LLMs. Okay. Why we want RAG? Generally normal LLMs, whatever we question, it gives the answer, but here you are querying on your own documentation so that you can get the data precisely and within a short period of time. Now let me show the context why we need Kafka RAG chatbot. Okay, let's think I have a documentation Kafka. Okay, these have 32 pages. In 1 hour or 2 hours, I cannot read these 322 pages. Okay, no human being can read that in one day. Now, what you want? I need what is producer API? Ni Kafka. I cannot just go to this 322 documentation. You can ask me like I have table of contents so that I can go. But even in table of contents, you can go to that particular page and you can see there will be a lengthy of answer for the particular Kafka producer API. Now with our chatbot, you can get that immediately. Okay, let's see how we do that. Our input data is our Kafka documentation. Now we can see what this chatbot does is. What is this about? Now if you go through this video completely, you can be able to create your own chatbot. Okay, so that it will be awesome. You can see what is this about. This is about Apache Kafka, a streaming platform that allows for publication and subscription of streams of data. It gives me in a precise manner. Okay, now I'll ask, what is Kafka producer and consumer? You can see I can go through the documentation that can, but it takes some time. But here it gives you the data immediately once you pass to the LLM. This is the Kafka RAG chatbot and it is very powerful engine. You can see in quick response you got this. What is Kafka producer and consumer? Kafka producer and consumer are APIs used for producing consuming messages in Kafka. The Kafka producer is responsible for sending messages to your Kafka cluster, while consumer is responsible for reading those messages. You can get these kind of plenty questions using this Kafka chatbot. Now you can see how we created this. Now let me go to the main algorithm which I used here and how to get. See, this is very optimized solution which I'm providing here. So please concentrate on this video. Let's design our model. Okay, how we are able to do this. Let us design this now. You can easily design this. Okay, for anything, for any algorithm, what we need is first input. Okay, we need input for this. Let me make this as an input. We can name this as an input file. Okay, we can make this as an input. File storage, we want this to be file storage. Total there, let's make this as 2 file storage. Okay, and then we need a text. These are the file storage, what we call as PDF files. We have now PDF files. Now what we need to split these files. These files contain 332 pages, so we need to split this. What we want this now to split this. Okay, uh, what we use this for splitting, we use lang chain. And what we use function, what the function which we use for this is the py pdf. Okay, let's see what actually we used for this. We use lang chain, okay, and text splitters for this, that you can see here. We used pdf loader for this. Okay, let's type here what we used. Py pdf loader we used. Next, what we want, these, once we split this, we want to chunk this. Okay, we use character text splitter. Where we used with 1000 chars and overlap of 200 chars. Okay, first what we did, we loaded the pdf files using lang pgf pdf loader. We loaded that, then we splitted that into characters using 1000 characters as chunks, and with overlap. What is meant by overlap? Overlap is nothing but if there is a line of 500 characters, the end line should not be divided to this plunk, okay, chunks. Okay, so we use this overlap in such a way that the character should not be separated between two chunks, so that there should be continuity. Okay, let's think about the pdf file which we were talking. Let's think this is this first one is our chunk 1, and this is our chunk 2. If the chunk 1 is of this and if chunk 2 of this, there is a separation between chunk 1. So what it does is, in chunk 2 it will start from this particular guide. Okay, so the chunk will start from this particular guide text. So every chunk have the continuity for the previous chunk, so the continuation will be there. Okay, I'll explain you in detail after that. Now we got character splits. Now what we want, now we want to embed this so that our model will understand. To store in the vector database, we need to embed this. For that we use Ollama models. For this, the whole structure we are using Ollama. Okay, Ollama, what we are using, which model we are using. Let me tell you briefly what model I'm using here. I'm using Nomic embed text. Okay, you can ask me which model it is. I'm using Nomic embedded model here. Okay, this is not pasting. Okay, which I'm using Nomic embedding model latest I'm using. Okay, then where I need to store this, I need to store in files db. Okay, for that I need a files db here. Files or Chrome I can use. Vector DB. This is the vector DB where it stores in the form of vectors. Okay, it does all the similarity searches here. Then what is next? Now 1 2 3 4 steps we did. When we build this application, these 4 steps will be stored. What it does, first the data will be splitted, then loaded, splitted, then using Olama embeddings it does embeddings. Embeddings is nothing but in the form of, it will be in the form of 0.1234. It will be in the form of binary mission readable languages, and it will be stored in the database. Okay, let's think this will be stored in 01. This is the Kalyan, this is Kafka. It will be converted into mission readable embeddings, and then it will be stored in files database. Now when the user asks any question, let's think when the user asks any question, user ask any question, what is Kafka? What is Kafka? Okay, these 4 steps. Okay, 1 2 3 okay, what is this? Okay, first 4 steps will be loaded when we start the application. You're getting right what I'm saying? When we start the application, all the documents which we pass as an input will be loaded using PyPDF loader. Loaded, then splitted. Second step is splitted. It will be splitted into chunks, and then third step is these chunks will be going into the Olama model, which we are using Nomic Embed Text latest model. It will be moved into that, and it will convert into machine readable binary language, which is nothing but vectors, and that it will be stored in files database. Okay, now we have the data in the database. Now if user questions query any question, okay, now this is the 5th step. If he query what is Kafka, it is again converted into Olama Nomic language, which is Nomic Embedded Text, and then what it does is it is again converted that into machine readable language, and it retrieves. Now this is where retrieval comes under picture. Okay, RAG comes under picture. RAG, what is meant by RAG? retrieval augmented generation. Okay, first in this, what is meant by retrieval? Retrieval is nothing but pulling the data from this FIRES database. First it pulls the data, then augmented. Now here comes the actual questions here. Now we come across now the LLM. Okay, we use Olamas, Mistral or GPT. You can get Mistral or Claude models here. From here it pulls the data using context and this prompt. Okay, prompt plus context. What it does, once if we query what is Kafka, it converts that into embedding. Okay, and then pulls the top three suitable results from this Chroma database. And then what is Kafka? It is nothing but Kafka is a streaming platform. What are the top three questions from this database? It pulls that, and then it pulls that and it augments. It's nothing but enhance with prompt plus context. It will push to the Olama, and this Olama model, Claude model, it will enhance the context, and then it gives beautiful response to the user. Okay, response, let's say Kafka is a streaming platform, blah blah blah. Okay, now this is the actual procedure. When the loading, when we start the application, first 4 process will be done. Okay, then 5th when user queries, then 6 queries, and then 7, then 8. Okay, 7 and then 8. So total 8 steps. Total 8 steps we have. This is the beautiful diagram which you can tell to your managers and anyone how to create a RAG. First PDF, then loading, then character splitting, then embeddings, then vector database. Then when you query, it pulls the top 3 latest answers and make that latest answer into prompt, and then it pushes that into your model, which is Mistral or Claude, and then finally your LLM gives the beautiful response to the user. This is how the chatbot is built. Okay, now let's see the code, what it does. Okay, let's do from the fresh. Okay, now we have a data in our data folder. Okay, so what we're doing, first we are loading the documents. Okay, we are building the first 4 steps. Okay, chatbot index builder. Once we load the documents, here we are loading the documents from this data directory. Step 1, we are loading either text files or PDF. If you can see the PDF, we are using PyPDF loader from the LangChain, which pulls the data and then stores in loader. Once it is loaded, it is converted. We want to convert that into chunks. For that we are using text split chunks. Okay, you can see here what we are using, recursive character text chunk. Okay, splitter we are using. Once we chunks that, next process is embeddings. Okay, once we chunk that, you can see all what we did, page.contains, everything will be stored in the metadata of these chunks. Then comes our embeddings. Next process is olama.embeddings. We are using nomic. You can see here, to start before this, okay, you need olama to be installed. Olama list, you can see there are two models, one is Mistral and one is this. The size of Mistral is 4.4 GB and the size of nomic embeddings is 274. How to download this? Just you can go to your browser, olama download, you can tell. It will ask where to download, Windows, Linux, Mac OS. Let's think I'm using Mac OS. Just download, it will be downloaded. You want to see which model to use. You can see there are n number of models here which are awesome, optimized. You can take. My current MacBook configurations are of 24 GB RAM I'm using. If you have more RAM, there is a chance of easiness. Okay, so use as much as RAM as possible in your lab so that your system won't stuck. Earlier I'm using 8 GB RAM in my Windows laptop, and if I run any model, it used to take 5 to 10 minutes to give the response. So I upgraded that to 24 GB RAM and I got my MacBook. So now it is easy. So because you may now be clear why models required GPUs. Currently I'm using just the RAM, 24 GB RAM. To run these models in the production, you need GPUs, which are very powerful systems to run these models, where they actually have, currently Mistral have 40 billion parameter. If you see here, DeepSeek is having 284 billion parameter. To run this, you need at least some time. Okay, you can see here, olama run pull. If you do olama pull card cloud anything, it will be downloaded to your local system. You doesn't need any internet for this. Okay, this is olama is just providing a fresh wrapper on these models, so be careful which model to use. So once you pull, it will be downloaded and then you can use that here. Now embeddings is ready. Now after this embeddings, you need to store these embeddings. Where you want to store this storage is nothing but files database. You will be stored in files database for this embeddings. You can see that here we are doing, I'll provide this whole code in my Git repository. You can directly download that. Okay, step 5 is now embeddings. You can store that in files database, files flat database. It will be stored in your own local storage. So once the database is ready, you can see now our 4 steps are ready. First for 1, 2, 3, 4 steps are ready. Now let's run this Python build. You can see here from the start what it does. First, it loaded 322 pages of Confluent Kafka definition guide. The summary of that is, it have one PDF file, there is no text file, total documents. In the sense, each page it is divided into documents. Okay, there are total 322 documents in this. Okay, you can see here it got index.files and docs.pickle file. I'll tell you what it is. Then it split it into chunks. 320 is divided, each chunk have size of 1000 characters and overlap of 200 characters each. So there are total 370 chunks. Okay, and average chunk size of 834 characters. Okay, you got it right what I'm saying. There are total 322 documentations, and based on that it divided into 390 and 834 characters. After this, it's processing the chunk metadata processed for 970 chunks. You can see here each chunk of example Neha Karkande, so on. So it generated 970 chunks. So chunks got created, then embedding started, successfully encoded 970 chunks, and then stored this vector database in FAIRS database. You can see the dimension is 768, data type for float. You cannot see what it is actually. It needs a separate cluster. It created pickle file as well as files. Files store here all the data, and pickle file stores all the metadata. Okay, creating files, index of type, files created, saving to the disk. You can see here in Chatbot, pickle file, metadata, and index both are saved here. Total chunks 970, index file size 2.84 GB. Now our basic metadata is created. Now the second user queries what is Kafka, it again goes and converted. Now let's start my process here. First step, prerequisites. You need to have Olama installed, then pull Mistral, and then requirements is Python. Install this Chatbot cd requirement. What are all the Python packages you require? Everything is filed in requirement.txt. You can just install at one go. These are the Olama LangChain, PDF, everything. Then step 2, create data directory. Data should be there where we need to add documents. Then step 3, build the vector database. You need to run build index.py. What it does: scans, loads, splits, generates embedding, stores in files database, create two files, index.files and docs.pickle. Then step 4, 2 ways to use Chatbot. Now I'll use the GUI based one, so I need to run Python rag Chatbot. This is for your CLI. If I type here hi, it is going to your Mistral via Olama. It gives you hello, how can I assist you? I have a question to provide. What is Kafka partition? Any quick answer, what is Kafka partition? By the way, your LLM gives. It's a subdirectory in your database. In Kafka. In a given context, Kafka partition is a logical division of Kafka topic. Each partition is embedded. You know, right? Why Kafka is important? I mean, what's the powerful engine for Kafka? It's nothing partition. Data get divided into these partitions. Okay. And each partition will have partition number 0. If a topic have 3 partition, data will be divided into 3 partition. You can ask me anything about Kafka. I'm a Kafka developer and Kafka engineer from past 6 years. I'm expert in most of the Kafka, provided many solutions to the application teams. You can ask me anything of that. Okay, it gives this answer. This is one way of providing the answer. Let's see the GUI representation for this. For this, you need to run rag Chatbot. You need to run a REST API for this. It is running, and then you need to we have a ML for this, documents, Python projects, Chatbot, front end. Okay, your bot is ready. Hey, what is Kafka replication? Any guess before giving the answer from the Chatbot? The data will be replicated into, if there are 3 brokers, data will get replicated into the 3 brokers, so that there will be resiliency for this. Kafka replication is the process of creating multiple copies of topics data across multiple brokers in a Kafka cluster. You got it right? And if a cluster have 3 brokers, data gets replicated into 3 brokers. If one brokers go down, there is a chance where we can get from other brokers. So the replication factor should be 3 while creating your topic, and partition is mainly for parallel processing. Okay, you got it right. Now what we did, similarly, you can do n number of what you call plum on this Kafka chatbot. Okay, now if I run this using unicorn, I'm using unicorn. Okay, you can then run this unicorn, where you can run this into the chatbot. Okay, sorry, I should move to API. I'm in chatbot. I need to search BNV ben activate. Okay, now go to your, I have provided everything here to access your Swagger API. You can go to here, that is docs. Okay, or directly, sorry, you can check the health of your chatbot, how the health is. Okay, the status is okay, and you can query your chatbot Kafka. You can ask what is this top here. It gives your top 3 pickups, latest answers, top 3 picks from your vector data. If it is 4, it takes 4 top picks. It gives response. Kafka is a topic covered in provided context. It gives you a context where it actually fetched, and it gives you the model which I'm using here. Okay, Mr. Okay, now I guess you might have got what we did. This is the entire Kafka RAG chatbot which we used here. Now let me explain you what is RAG here. Okay, example, what is RAG? Retrieval plus augmented generation. It is a 3-word term which provides you the actual meaning for the RAG. What is meant by retrieval? Retrieval is nothing but, for the name you can find. Augmented is nothing but enhance. Generation is nothing but create. Let's break down retrieval. What is meant by retrieval? Once you store the data in your vector database, from here you need to retrieve the data which is suitable for your question. What is Kafka? So in a database, what are all the meaningful words for this? What is Kafka? It fetches top 3 suitable words from this database. This is nothing but retrieval. Okay, you got it right. Convert, you can see example here. Search for the retrieval document for chunks. Convert user questions to vector. Search files database for similar vectors. Retrieve top 10. That is nothing but retrieval. User asks, what's our return policy? System such as knowledge base retrieves chunks. Retrieve, it gives top 3 vector similarities. Return policy 30 days allowed. Wherever there is return, it will give that. Items must be original condition, refunds. Now, real world analogy comes into the picture. Asking a question is nothing much important, but the beautiful answer is what matters. Once you question this, what it does, vector search top 3 output. Okay, now augment comes into the picture. Augment is nothing but make better. This is where your prompt engineering comes into picture. Okay, you need to learn about prompt engineering also. For this, I'll explain to you in detail how to become an expert in this chatbot. Okay, please follow my YouTube channel, which is nothing but A Quantum Nova. Okay, A Quantum Nova is my YouTube channel. You can follow this for your AI as well as quantum engineering. All videos will be published into this channel, which is nothing but A Quantum Nova. Now this is augment, make better for your complete answer. Whatever the prompt you give to the LLM, that is how the LLM will learn and it gives you the output. It is nothing but whatever you make your child learn in the childhood, then only he will learn and he will enhance his brain power increases. If you make your child as a dumb, even if he grows, he will be dumb. Okay, that is where input to this LLM is an important. You need to have a precise English nomenclature for this, okay, to enhance your output. What is the return policy? Augmented prompt. Use this context, your retrieved company docs. What is the return policy? This is your prompt for the LLM. So this gives the best answer for this. And then generation. Generation is an LLM generate the response and it gives the output. Okay, that is how it works. First is retrieval. When you pass the sixth condition, it retrieves. Then prompt plus context is nothing but your augmentation, and eighth one is nothing but your response. Okay, 6, 7, 8 is your retrieval augmented generation actually comes into picture. This is the whole documentation, everything I'll provide in my Git repository, and then in YouTube in the under the description you can see everything. Okay, that's it guys, thank you, bye bye.